Hello there guys and welcome back to another epic Inexorable maths video. In this video we have got yet another integral that you simply must know, and this also involves trigonometry quite strangely. Again, look at this integral for a moment guys. Is there any indication at all that this is equal to a function related to trigonometry? I don't think so, but it is. That is what it is. And we're going to have to do a substitution which allows us to simplify this integral. And again, just like in the last video, link in description to the last one, just like in the last video, we're going to see that the substitution that we're about to use, although it seems really random because it's related to trigonometry, when it doesn't look like it should be, it's actually going to make the integral so simple that this will become the integral of just the number one, which is a pretty good substitution. So let's just dive straight into it, guys. So the substitution, even though it probably seems very, very random and strange, we're going to let x be equal to tan of some variable theta that we're going to make up, okay? So x is tan theta, okay? And then we're going to do the normal stuff that we do when we do an integral by substitution. So we need to see what d theta is, so dx d theta. The derivative of tan is sec squared. So we have that dx d theta is sec squared theta, which means that dx is going to have to be sec squared theta times d theta, like that. Okay. Now let's take our integral, and I'm going to call the integral I, by the way, guys, just so it's easier for me to refer back to it. The integral I is equal to now 1 over 1 plus x is tan theta, so tan theta squared, which is tan squared theta there, times dx, which is sec squared theta d theta. So sec squared theta d theta. Amazing. Okay. Now, you may say, thank you very much. You've made my integral so much more complicated. What on earth is that? That looks like a complete mess. Well, actually, if you know your trig identities, it's not quite a mess. So, if you already know, I mean, you might already know the identity, but if you know that cos squared plus sine squared is 1, which you should do, because it's true, then all you have to do, guys, is just divide everything by cos squared. And you're going to get that 1 plus tan squared is 1 over cos squared, which is sec squared. And look at that nice identity. 1 plus tan squared is actually equal to sec squared. We have a 1 plus tan squared right here. So the denominator of this fraction is just sec squared. So the integral is just the integral of sec squared divided by sec squared. Which, guys, what is anything divided by itself? Well, just 1. So this is the integral of the number 1. Neat, right? And guys, what does 1 integrate to? Don't say x, because it's actually theta, because we're integrating with respect to theta, okay? So it's theta plus c. So this is equal to theta plus c. The final step is that we need to replace theta with what it is in terms of x, okay? Because if someone said to you, hey, what's the integral of 1 over 1 plus x squared? And you said, oh, it's just theta plus c. They'd go, what on earth are you talking about, mate? What is theta? Well, we're going to replace theta with what it is in terms of x. We know that x is tan theta, which means that theta, if we take inverse tan on both sides of this, theta is equal to arc tan x, okay? Arc tan x, which some people like to write as tan to the minus 1x. Inverse tan, arc tan, they're the same thing. They're literally identical to each other. They're the exact same thing, just different notation, whichever one you prefer. And that is what we would put here. So the integral is equal to arc tan x plus c. And I'm just going to write that result out. It means that the integral of 1 over 1 plus x squared dx, believe it or not, is equal to inverse tan, if I can spell, inverse tan of x plus c. I know how random it looks, but it's pretty crazy. So again, this is an integral that you would probably not be able to just randomly answer. Like, who would think to do that? The substitution you would likely guess is let u equal x squared, or let u equal 1 plus x squared, but actually it's not any of that. you need to let x equal tan of some variable, which is not obvious. So it's good to have seen this, have someone shown it to you, because it's very difficult to come up with on your own. So now that you've seen it, you can't unsee it. Remember how to do it, guys, and there'll be more integration videos coming at you soon in the future. But for now, thank you so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.